Hello everyone, welcome back. This is lesson number 8 for Calculus AB, where we're taking derivatives of trig functions. In the very first video, we took the derivative of sine, cosine, and tangent, and we found out what those values were. In video number 2, we did practice examples using mostly the derivative for sine and cosine, where we added a couple more problems to it, but we found all first derivatives. And in this video, we're going to do second derivatives. We're going to find some derivatives of trig functions for the second derivative. So right now, I want to say for derivatives, what you are probably used to seeing with notation is f prime of x that represents a first derivative, and then y prime is also a first derivative. What you're going to be really good at in calculus at the end of the year, and hopefully pretty soon now, is notation. You're going to be able to see something, read something, and know exactly what it means. So the one that we use the most, the one that I like the most, is this derivative notation. It's the derivative of y with respect to x. Okay, so we're taking the derivative of a y function with respect to x. I spend more time on this when we talk about implicit later on. So this is our first derivative. This is our first derivative. All right, and so if we want the second derivative, well, it would be f double prime of x, or it'd be y double prime. But if we want to take the derivative of our first derivative, we're going to get this notation right here. You guys can see that there's an L2 here and a 2 here. So I want to just generalize by saying if you see d to the n y over dx to the n, then this is asking us to find the nth derivative, okay, the nth derivative. But we're not going any further than the second one today, right? We're just going to go and do some basic second derivative tests. And so let's actually start an example. And what I want to do is I want to rewrite this before we start. And I only want to rewrite the last part. I'm okay with the 7 sine x. I'm okay with the 3 cosine of x, but I want to rewrite this as 3x to the negative 1. 3x to the negative 1. I tell my students, and I want you guys to know that there's 2 functions that you should know your derivatives of very easily. 1 over x being one of them, and then the square root of x. I think those 2 functions are really helpful if you know them very quickly, because I can do this derivative pretty fast, but we're going to go and do it slowly here for us. So let's look at 7 sine of x. So we had a conversation in video 2 about a constant and a trig function. The derivative of this is just simply going to be 7 cosine of x, right? Just the derivative is just the number and cosine of x. And then the same thing over here. It's going to be negative 3, and then I'm going to take the derivative of cosine, which is negative sine. So I'm going to go ahead and make it positive, negative sine. And then this one right here, ladies and gentlemen, it's going to be move the negative 1 down, so we're going to use the power rule. So negative 3x to the negative 2. And again, this is equal to our very first derivative. Okay, so y prime is good, so is dy dx. If I want to find the second derivative, I'm okay leaving my negative exponent alone because it'll be easier when I find the second derivative. So y double prime, which again would be d squared y over dx squared, then we're going to find the derivative of this thing. So it's just 7 cosine of x. It's like finding this one now here. So the derivative of 7 cosine of x will be 7, and then the derivative of cosine is negative sine. Remember that we said in the first video that if you begin with the c, we change its sign, right? So negative 7 sine x. Then I'm going to do plus 3, and the derivative of sine is going to be cosine of x. And now we can find this derivative here by moving the negative 2 down and multiplying it by the negative 3, and we get positive 6x to the negative 3. And so our second derivative is just going to be negative 7 sine of x plus 3 cosine of x plus 6 over x cubed. Okay? And that is it. That's what we have to do for these problems. It's just go step by step by step and do that. All right, so let's look at another example. So for questions 8, 9, and 10, it's asking us to find the second derivative. All right, it's asking us to find the first and second derivative for these questions. So let's actually look at them because some of them are actually not too challenging to do. I'm also thinking that sometimes, guys, as a strategy, you want to rewrite your function first before you actually start solving it. Now, for example number 8, we're going to leave it alone because we're actually very happy with the simplicity that is this problem. And so we're going to go ahead and find the derivative of each of these terms independently. So the derivative of 2x is just going to be 2, and the derivative of negative 2 cosine of x, well, again, we can leave the constant, negative 2, but again, I'm taking the derivative of cosine, Well, the derivative of cosine is going to be negative sine, which means we again have to change the sign. And so we get 2 plus 2 sine of x. And then we don't want to pull a 2 out because we don't want to create a product rule problem, right? So we want to go ahead and find the second derivative. And we find the second derivative of this. Again, we're going to take the derivative of 2, which is just 0. And so this actually goes away. This becomes 0 plus, and then the derivative of 2 sine of x is going to be 2, again, our constant. And then this derivative of sine is going to be cosine of x. So our second derivative is just going to be 2 cosine of x. And that's it. Pretty straightforward question that we like. For question number 9, I see rewrite. So I'm going to go ahead and write stuff out because we want to keep it as simple as possible. So this is going to be 2 over x to the 1/2 power. Well, I want to change that and make it x to the negative 1/2, right? X to the negative 1/2 power. Because again, I can do what I did in example number 7. I can just go ahead and use the power rule here with the negative exponent. And then minus, I don't want to use the quotient rule here. There's no need to use the quotient rule here. You guys remember back in probably the first or second day of pre-calculus that 1 over cosecant is the same thing as sine. So we're just going to go ahead and write this as just sine of x. Because how much easier is it to find the derivative of sine than it is for me to do 1 over cosecant of x. So now I've rewritten it. I'm a very happy person. And so now I'm going to really go ahead and start working on the problems. So the first derivative, I'm going to move the negative 1/2 down. I'm going to multiply negative 1/2 by 2, and I'm going to get negative 1. I'm going to get x to the 1 less power. So be very, very careful when you do this. It's going to be to the 1 less power. So it's going to be to the negative 3 over 2. And then the derivative of negative sine is just going to be negative cosine, right? We don't change the sign in front of it because we're taking the derivative of sine, which begins with an s and not a c. So let's look at the second derivative. So f double prime of x. We're going to move the negative 1/3 over 2 down, and multiply by the negative 1. I get 3 over 2. I get x to the 1 less power. So it's going to be to the negative 5/2. And then I'm going to take the derivative of cosine of x. Well, again, as I'm taking the derivative of cosine, I'm going to change the sign in front of me. So it's going to be sine of x. So if I just really quickly rewrite this, the 3 is in the top, and then the 2, x to the 5/2 is in the bottom, plus sine of x. Okay? Pretty straightforward with that. I'm going to go ahead and do a different kind of type of problem now. Number 10 is very similar to question number 9, and so is question number 11. So let's look at questions number 12 and question number 13 and do these two questions. And we'll see what we can do with it. So question number 12, it says sine squared x plus cosine squared x. And I just want you guys to know that, yes, this is an identity, right? It's an identity. It's just 1. Okay, it's just 1. So the derivative of, f of x is equal to 1. So the derivative of this function is going to be 0. And the second derivative of this function is also going to be 0. You're going to learn in the next lesson something called the chain rule. And we will hopefully come back to this question and I can show you guys how to do it through the chain rule and still get that the derivative is going to end up being 0. Okay? So we're good with that problem. So remember, identities. And so I'll have a list of stuff in class for you guys of what identities that you need to know. All right? So this is one of the most classic ones. And then lastly, number 13, it's 5 times x times sine of x. So yes, you could think about this as 3 products or 3 functions being multiplied together, but for the product rule, we need 2 things being multiplied together. So we're going to put the 5 and the x together and the sine of x by itself. So let's go ahead and find the derivative of this first one. And so I'm going to do the first, right? And then I'm going to find the derivative of sine, which is cosine of x. So I'm using the product rule, plus the second times the derivative of the first. So I'm left with this problem, and I'm going to rewrite it for us here. So I've got 5x cosine of x plus 5 sine x. Now, in order to find the second derivative, I actually have to see that there's 2 things I have to do here. So the first one that I'm going to acknowledge is that I have to use the product rule here, right? It's the same thing as we did right here. So I have to use the product rule here, and then a very basic derivative right here, right? It's just 5 sine of x. But I can't forget about this term. I can't forget about it. So actually, let's start working on the second derivative. And the first thing is I'm going to do what's in purple. All right, we're going to write down what's in purple. So again, it's going to be the first, which is the 5x, and I'm going to multiply by the derivative of what's in the derivative of the second, which is going to be negative sine of x. I always like to put a parentheses around this when I'm doing a negative. That way I know that I'm multiplying 5x times this, and so I don't look back at my problem and think, oh, it's just 5x minus sine of x. So that's just a nice little strategy that I do when I'm doing my problems, to put parentheses around it, so that way you guys can just, make sure that you need to differentiate between multiplication and subtraction. Okay, so where were we? So first times the derivative of the second, plus the second times the derivative of the first. Okay, and then we have to should not forget to find the derivative of this. So this is going to be plus 5, and then the derivative of sine of x is going to be cosine of x. Okay, cosine of x. So we can simplify a little bit here, although it's getting pretty crazy, but we can simplify a little bit this one. So we have negative 5x sine x, and we have a 5 cosine x plus 5 cosine of x. So that's going to give us 10 cosine of x. Pretty awesome question to do. All right. All right, I got one more I need to do with you guys. Hopefully that makes sense. So find the first derivative and then go ahead and find the second one. Again, don't forget about the product rule and the quotient rule as you're doing the problems. So the last thing that I want to do is talk about finding the equation of tangent lines to the following curves at the indicated point. Confirm your slope using a calculator. So we're not going to actually find the slope using the calculator, but we're going to go ahead and find these derivatives of our functions at our values. So the first thing is if we want to find the equation of the tangent line, we need a point. So we have a point x equals 0. If I plug in 0 to our function to get our corresponding y value, well, the sine of 0 is just 0. So 0 times cosine of 0, which is 1, it's going to be 0. So we're actually at the origin for this problem. So that's actually a little kind of boring. But over here for this one, we have pi as our answer. And so our numerator is going to be 2 pi plus 1. And our denominator is going to be cosine of pi, which cosine of pi is going to be negative 1. So we're going to have our point, which we're going to modify a little bit later. So how we get our point is taking the function x that we're given, and we'll plug it back into the original. So that's always the first thing that we want to do. To find the actual slope, right? The slope, because what we're looking for here is we're trying to find y minus y sub 1 is equal to the derivative, right, which is our slope, times x minus x sub 1. So our x sub 1s are here, our y sub 1s are here, and now we want to find what our actual slopes are. So dy dx, which is our y prime, right, is going to be equal to, again, we've actually done this example before with one of the problems we did in this video lesson. So it's going to be the product rule. So I'm going to really quickly just write down that it's going to be the sine of x times the derivative of cosine of x plus cosine of x times the derivative of sine of x. And when we actually get this said and done, we get that this is actually going to be cosine squared x minus sine squared x, which we've also discovered is cosine of 2x. And the easiest thing about this, ladies and gentlemen, is that if we want to find the derivative of this, we want to evaluate this at 0, 0, or x equals 0, however you want to do it. So it's going to be the cosine of 2 times 0. And so the cosine of 2 times 0 is just the cosine of 0, which we know is 1. So our derivative is 1. So how easy is this equation, right? So our derivative is 1, and our point is 0, 0. So it's going to be y minus 0 equals 1 times x minus 0. So this function is going to be y equals x. Okay? So the equation of the tangent line of this function, sine x, cosine x, at the origin is just 1, y equals x. Pretty awesome stuff. Then the last example that we're going to do, ladies and gentlemen, dy dx, we're going to find this derivative using the quotient rule. So we're going to go ahead and do low, which is our denominator, times derivative of our numerator, minus our numerator times the derivative of our denominator, which again, how many times have I said it now, right? The derivative of cosine is negative sine all over our denominator squared. And now, ladies and gentlemen, strategy time. Strategy. Don't simplify. All we have to do now is we want to figure out what's happening when x is equal to pi. So let's plug in pi. Let's plug in pi here. So cosine of pi, right? And we want to square it. So cosine of pi, and we want to square this. Well, cosine of pi is just -1, so -1 squared is actually equal to 1. So our denominator actually is just 1. So really just our value for our slope is just what the numerator is. Well, let's figure this out. So cosine of pi is going to be equal to -1. Oh God, that's not a bad, it's a horrible -1. What was I doing with that? -1. And then I'm going to multiply that by 2. Minus 2 pi plus 1. So everywhere I see an x, I'm just putting into pi. But when we put in sine of pi here, well, sine of pi is 0. So then this term goes away. So then our actual slope ends up being -2. So finally, we can say this problem, the answer for this equation line is going to be y minus, I'm going to go ahead and just make this a negative. I'll just put it outside of there. So I'm going to do this. So it's going to be minus a negative, so it's going to be plus or positive. And I'm going to go ahead and do 2 pi plus 1, even though I don't technically need that, is equal to -2 times x minus pi. And this is how you get the equation of the tangent line for this problem. So what do we do for these problems? We plugged in x to our original, and that gave us the y coordinate of our point for our tangent line. And then we took the derivative of our function. We used the product rule here. We used the quotient rule here. And then as soon as we found that derivative, and as a matter of fact, ladies and gentlemen, what I could have absolutely done in number 20 is I could have plugged in 0 here, 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 and here. And that would have been so much easier because sine of 0 would have been 0. This term would have completely went away. Then the cosine of 0 times the cosine of 0 is just going to be 1 times 1, which is 1. So I could have absolutely, and that's what I always tell students, is once you get a derivative and you have a value for x, plug it directly in. So I didn't even need to do any of the rest of this stuff. So I should have just said that. But right here, I did it. I plugged in exactly once I found my derivative. I found that my derivative was -2, and then I went ahead and plugged it into my point slope. So that is it, ladies and gentlemen. I just want to say really quickly, I'm looking at number 22 here. It says the normal line is perpendicular to the tangent line. Find the equation of the line that is tangent to the normal line. That is tangent and normal to the curve at this point. I'll just say, ladies and gentlemen, that if I asked you to do the exact same question for question number 21, and I asked you to find the normal line to this one, right, then all you would do is you would have the same y value, and then you have the same x value. It's just that the normal line, if it's perpendicular to the tangent line, then you're going to do the opposite reciprocal. So it'd just be 1/2. So when you do example number 22, then you do the same thing. You're going to do the same thing. You're already given the point, right? It's pi over 4, 1. Find the derivative of this. It's really basic. It's just the square root of 2, which is a number, times the trig function. And then all you have to do is just find that, plug in your value, pi over 4, to get your slope of your tangent line, and then do the opposite reciprocal for your number line. Okay, so that's been a lot. So hopefully you guys understand a little bit better now the derivative of your trig functions. And so we're going to start talking about the chain rule next, and that will be in lesson number 9. So I'll see you guys in the next video.